Alright, we're going to look at parallel resistive circuits and go over an example problem with you. So, some characteristics of parallel circuits: they share the same voltage, total resistance is added reciprocally, and current into a point equals current going out of that same point. So that's when we get into Kirchhoff's current law. So here's an example of a parallel circuit. Alright, and so the applied voltage is 120 volts, and because they are all connected up in parallel with it, each resistor will see 120 volts across each one. So they have the same voltage. So V total, or the applied voltage, is going to be the same as V1, same as V2, and same as V3. So we can also determine the current flow through each one of these branches. So 120 divided by 6, we're looking at 20 amps through branch 1, through branch 2, 10 amps, and through branch 3, probably 30 amps per branch. Now, this is review of first period basic parallel circuits. So we have all resistors, meaning all current will be in phase with the voltage. So Kirchhoff's current law would come into play here, and the total current, we put an ammeter right here, that will give us our I total. So the current in the circuit, if we add up each branch, I1 plus I2 plus I3 is how we got current parallel. So that's 60 amps. So if we know the total current in the circuit and the applied voltage, we could determine the total circuit resistance from this by using Ohm's law. So I total is equal to E divided by R total. And if we want to find R total, we would go applied voltage divided by I total, that's 120 volts, divided by 60 amps. So the R total is 2 ohms. So we're just going to look at the reciprocal formula, and we are going to confirm that. So if you remember back from your formulas, so you would have seen something like this for parallel circuits: 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R3. Okay, so that's one way to write it. There's another way, and this coincides a little more with your calculator. So if you go RT to the minus 1 is equal to R1 to the minus 1 plus R2 to the minus 1 plus R3 to the minus 1. Okay. Let's go ahead. I'm going to bring up my calculator, and I'm going to show you what this would look like. So if I was going to use either formula, I'm going to use the one I like here. So it's very functional with your calculator. The same formula, just written differently. So RT would be equal to bracket R1 to the negative 1 plus R2 to the negative 1 plus R3 to the negative 1 and bracket and negative 1. I'm just going to pull up the calculator here. So if I were to enter this in, I would simply go bracket 6, second function 2 plus 12, second function 2, you can see the x to the minus 1 there, plus 4, second function 2, and bracket, and second function 2, and it equals. So there's your R total. R total is equal to 2 ohms. So the reason why I like using this formula, I find it really quite easy to move stuff around. So if I knew the R total was 2 ohms. And what I just calculated, and I wanted to figure out a different value, let's say R3, I could just rewrite the formula. R3 is equal to R total to the negative 1 minus R1 to the negative 1 minus R2 to the negative 1. That in brackets, reciprocal the whole thing, and I should get the answer. So let's just try that calculator out again. Our R total was 2 ohms, so if I wanted to use that to solve for R3, I would just go bracket 2, second function 2, let's take away R1, which is 6 ohms, second function 2, we'll take away R2, which is 12 ohms, second function 2, and bracket, and reciprocal the whole bracket, so second function 2, equals, and we got 4 ohms. There you go. Okay. Yeah, so a little bit about parallel circuits. So some things you'll notice that the total resistance is always going to be lower than any single value. And the more resistors we add in parallel, the more current flow we're going to have, and the less the total resistance. So you may be asked to manipulate some of these, increase resistance here, decrease, or open up a branch or take away a branch. If you have to, you can put in numbers to do that. I like to think of that in terms of current. The higher the I total, the less resistance. So by adding a branch, current goes up, resistance goes down. If I take away a branch, current would go down, therefore resistance would go up. So I always think of it in terms of the current and what's going to happen to the I total if I add or take away branches and manipulate one branch. Hopefully that helps you out, and we'll see you in the next video.